Let's finish up Chapter 1 and Section 1.3. We're talking about sample data, and so we're going to talk about different ways we're going to collect our sample data. And remember, data from samples are called statistics, and you need to have the best data you can gather. And how you collect that data makes a big difference on the quality of your outcomes. And the most important thing that we are going to deal with is we are going to deal with most of our samples will be simple random samples. If you're asked a question and it says what type of sample does this statistical analysis work with, simple random samples always the best answer. As our data collection gets more complicated, the analysis needs to get more complicated also. The gold standard of collecting data is a randomization using a placebo group and a treatment group, and it's because it's so effective. Now, placebo is a sugar pill that has no medicinal effect. There's a link in the PowerPoint if you open up the PowerPoint file that you can go to, and it's a TED Ed talk that takes about 4 minutes to explain the placebo effect if you're interested in that. Okay, now observational studies are just that. They watch, you observe, and then you're measuring specific characteristics. But there's no attempt to modify what the subjects that are being studied do. Now, in experiment, there is a modification imposed. We call it a treatment. It's not always a medical treatment. It might be looking at how fragrance affects people. Maybe we're going to do a study in a department store, and we try different fragrances in a department on different days to see if buying is higher with different kinds of fragrances in the air. So we're applying a treatment, we're observing the effects, and we call them subjects when they're human beings, otherwise we call them experimental units. They're the same thing. But the important thing about an experiment is that there is a modification imposed. Why don't we always use an experiment? Well, sometimes it's unethical. So for instance, if I'm going to test a new cancer drug and I find 100 people with cancer and I randomly assign them to a treatment group and a placebo group, is it ethical to make people think they're getting a treatment when they are not? I will also tell you that there are some things you cannot control. So you cannot assign people to be left-handed. You cannot assign people to be male or female. There are just some things that cannot be randomly assigned. Now, I will talk about some unethical experiments, and that's what happened in the Nazi concentration camps during World War II. When there were twins that were getting off the trains to the concentration camps, the twins would be split. One would go with the parent and one would go to an officer's home and be fed and treated just like the officer's child. Then after a certain amount of time, those two twins would be reunited. They'd be given a disease like typhoid or dysentery or cholera, and they would see, the German doctors would see how long it took them to die. If the twin in good health with good a nutrition survived longer than the twin who had substandard housing and substandard nutrition survived. So let's look at some specifics about simple random sample. First of all, when you have a simple random sample, samples of the same size all have the same chance of being chosen. So if I have 100 marbles in a bag and I pick out groups of 10 from the bag, every possible group of 10 has the same chance of being chosen. That's a simple random sample. Where when we leave the simple part off, when we have a random sample, that means each individual member has the same chance of being chosen. And then we have a probability sample, and a probability sample is if you want to get a sample of a certain size from the students at a four-year college, and I'm going to simply make it simple. So you have 250 freshmen, you have 300 sophomores, you have 200 juniors, and you have 250 seniors. So we know that each freshman and each senior has a 250 out of 1,000 chance of being selected. We know each sophomore has a 300 out of 1,000 chance of being selected. We know each junior has a 200 out of 1,000 chance of being selected. So that's what a probability sample means. So you would find a set of random numbers on the computer. You would have numbered all your individuals, and then you use the random number chart to help you pick those. Okay, what I want to do is I want to show you some things that you have access to, the appendix, Appendix A. But what I wanted to show you is I wanted to show you this barrel fold tables. If you bought a hardcover book, you get a fold out on heavy paper that has all these tables in them. I will attach any appropriate tables to the exam for you to use when you need to have your exams proctored. When you're taking the test at home, I would recommend you print these out and you look at them so you know. But you've got 8 pages that are going to be really good references. And so it's barrel fold tables, and you'll find that in the table of context for your ebook. So for random sampling, you would number each individual, and then you'd go to a table of random digits to help you pick those. In systematic sampling, you select every certain number of elements. So for instance, let's say that I'm going to work in a candy bar factory, and the process is to pick every 50th candy bar coming off the line to send it to quality control. So the 50th one, the 100th one, the 150th one, that would be systematic sampling. And then there's the convenient sampling, where you just use results that are easy to get. You walk down the hallway at school and you ask people, hey, will you take my survey? Or voluntary response is convenient sampling, where I put the question out there and I wait for people to call in or to text me or whatever. And then there's stratified sampling. Now, if I want to make sure that I have equal number of men and women in my study, I might split them into men and women and then randomly select 25 women, 25 men to use as my subjects in my study. So remember, strata means layers. If I go back to that college example, and I want 10 freshmen and 10 sophomores, 10 juniors, and 10 seniors, then it's going to be important for me to split them into groups and then randomly sample from each of the 4 classes. That would be stratified sampling. Now, cluster sampling is if this is a picture of a city and the precincts, I would randomly select the precinct, but then all of the members in that precinct will be interviewed in cluster sampling. And then we have multi-stage sampling, which is some combination of what we just talked about. And they don't all have to be the same sampling technique at each stage. So let's say I'm going to take a random sample of 10 states, and then I'm going to pick 10 counties, and then in the counties I'm going to pick 10 townships or parishes, and then I'm going to look at everybody in those parishes and townships. So we have random sampling, systematic sampling, every 5th person, every 25th candy bar. We have convenient sampling, which is not good. We have stratified sampling, where we need to divide them into groups before we randomly sample. And then we have cluster sampling, and then of course the multi-stage. First of all is a cross-sectional study. And so the data are observed, measured, and collected at one point in time. So think about this. If I'm going to saw through a limb, the data that I'm going to have about that tree just comes from that one slice. So cross-sectional studies, we look at one slice of the picture. The study I did was cross-sectional. I looked at first-time full-time freshmen who went through orientation at Iowa State University. I think it was 2006, 2007, and 2008. Now, a retrospective or a case control study is we go back in time. We go back in time by examining records, which is probably the most reliable. We might interview people, but then we need to worry that we are getting their recollections, and their recollection may not match what other people experienced. And so a retrospective goes backwards to the past. And then we have prospective studies, which are also called longitudinal or cohort studies. So data are collected from groups going forward. If in 2014 you saw the movie Boyhood, they follow a boy from I think preschool till he's ready for college. That would be a prospective study. In Britain, I think it was in 1965, and the sample was not scientifically chosen, but what they did was a director made a film called 7 Up. So they took, I think, 47-year-olds and they interviewed them about things. Well, 7 years later, they did the same thing to as many of those 7-year-olds they could find when they were 14. And they've been doing them every 7 years. So if you want to look that up, you want to look up the 7 Up study, and you can read more about that. But again, that sample was not a scientifically chosen sample. It was just a sample. Again, randomization is when we assign subjects to different groups. Okay, so let's say I've got 25 people and I want to put them in two different groups, and I have each of them roll a die, and those that get even numbers go to one group, those that get odd numbers go to another group. Blinding is when the subject doesn't know whether they're receiving a treatment or a placebo. Now, a placebo is it's fake. So when they did studies on the nicotine patch, they took smokers, they put them into two groups. Since there wouldn't be any more harm done to the people who were getting a placebo, some of the people got, let's say it was a blue Band-Aid with the nicotine in it. Some of them just got a blue Band-Aid that didn't have anything in them. And then they compared how the two groups compared with smoking cessation. So what was the rate of quitting in each of those groups? Now, they have to be careful of the placebo effect when that just means that sometimes when people are given something, a shot, they think they got something, so they want to feel better. Now, a double-blind study means the subject doesn't know whether he or she is receiving the treatment or placebo. That happens almost with everyone. Okay, so that's true. But with a double-blind study, the treatment provider also does not know. Now, of course, the study designer and the data analyst know who gets treatment and who doesn't. Otherwise, they wouldn't be able to give us any results. In this case, this is the nicotine study, and so again, you can read that on your own. And a not double-blind study would be using music on relaxation. So what happened is they took music. Some people got music, classical music, and then they took the basic IQ test. Now, of course, the participants knew if they were listening to music or not, but those who were measuring the IQ didn't, so that was single-blinded. Now, confounding occurs when the experimenter is not able to distinguish between the effect of different factors. Okay, so let's say I'm going to do a study, and I think that maybe shoe size is tied to reading skill. And I do a study and I give students from in elementary school, so let's just call that first grade to sixth grade, and I'm going to give them a reading test. And I'm also going to measure their foot length. Well, I do some fancy math and I find that their foot length is very associated with their reading skills. So people with big feet read better. Well, if I'm looking at elementary school students from first grade to sixth grade, what else is happening there? I hope you're thinking, well, in first grade they're 7 and in sixth grade they're 12, and we hope 12-year-olds read better than 7-year-olds, and we also would figure that 12-year-olds probably have bigger feet than 6-year-olds. So that data could be confounded by the age of the child and would not be a good design. We should design it differently to try to eliminate the confounding of our results by age differences. When we do experiments, we randomize the subjects so that any confounding would even out across groups. But when we do observational studies, there are ways to adjust for some of these variables, and that gets into some fancier statistical techniques that are beyond the reach of this course. So what happens? We're going to completely randomize experimental designs. We can have randomized block designs. So in other words, we take a block of subjects that are similar. Like we might take, let's take 15 first graders, and then 15 second graders, and then 15 third graders. And then we do our reading study and we'll look at how the blocks compare to each other. We can do a control design, and that would be a full-fledged experiment, or there's another design called match pairs design where we match people somehow. An example of a match pairs design is a before and after. So when you were in elementary school, you might have taken a spelling pretest on Mondays, and then you went through the spelling activities in class, and then you took your spelling post test on Fridays. Chances are you did better on Friday than you did on Monday, so you looked at how well the spelling curriculum helped you improve. Or another study that one of my other textbooks talked about, they took romantically linked couples, and they interviewed the women and they interviewed the men, and they compared their responses, and those couples were matched. Or if I wanted to look at, let's do reading again. I want to look at the differences between schools in the suburbs and schools in the inner city. I might match the students according to their Iowa Test of Basic Skills scores, so that things are as even as I can make them between the two individuals. We need to talk about errors. We have a sampling error simply because of chance fluctuations. We do what we can to avoid sampling error, and that's where simple random samples help us as much as we can. And then there's non-sampling error. So for instance, we talked about biasness in the last lecture. So if I have a police officer going door to door to interview people about drug use, I have introduced bias in my answers. Or the convenience sampling introduces bias. Let's say I'm using a survey and it's a really bad survey. That's non-sampling error. Or let's say that I have a survey and I misrecorded some of the answers that I was given. Those would be non-sampling errors, and we do our best not to make those. Now, we have some active learning questions here. What I'd like you to do with these is take a minute, work on the answer, and then I'll leave each question up for 5 seconds, and then I'll show you the answer. If you need more than 5 seconds, then go ahead and pause the video.